We know how to add two vectors. We know how to subtract two vectors. Also, we know how to multiply a vector by a scalar. Now, let's see how to multiply two vectors. Two or more vectors can be multiplied in various ways. One way is called what? The dot product. Another way is called what? The cross product. If we consider three vectors, then we can define scalar triple of three vectors. And if we consider the cross product of the three vectors, that is called vector triple product. So let's see one by one: dot product, cross product, scalar triple product, and vector product of the vectors. Suppose A bar and B bar are two vectors. Suppose this is the vector A bar. This is the vector B bar. These are co-initial vectors which are originating from what? The same point. Suppose theta is the angle between these two vectors A bar and B bar, which are directed as given here. So suppose this point is O, this is A, this is B. So angle AOB is the angle between the two vectors A bar and what? B bar. Then we define the dot product of the two vectors as A bar dot B bar. This is the notation. Now we define this as the magnitude of the vector A bar, that is mod A bar, into magnitude of the another vector B bar, that is mod B bar, into cosine of the angle between the two, that is cos theta. So dot product of the two vectors is denoted by A bar dot B bar. Dot product of the two vectors A bar and B bar is denoted by what? A bar dot B bar, and is defined as magnitude of the first, length OA multiplied by length OB into cosine of the angle between them, that is what? Cos theta. Now notice that A bar dot B bar, by definition, this is a number, and this is also a number. So product of three numbers is again a number. So dot product A bar dot B bar is a scalar quantity. Hence, this product is also called a scalar product of the two vectors. Now, mod A bar is positive, mod B bar is positive, but theta could be either acute or obtuse or right angle. Therefore, depending upon the choice of theta, this product would be what? Either positive, negative, or zero. If I consider theta acute, theta in between 0 and pi by 2, then cos theta is positive. Therefore, everything in the right hand side is positive. Therefore, A bar dot B bar is positive. So, whenever dot product of the two vectors is positive, then cosine of the angle between them is positive. Therefore, what? This theta must be what? Acute angle. Or whenever angle between the two vectors is acute, then dot product is what? Positive. If I consider a special case, theta is equal to pi by 2, then we know that cos pi by 2 is 0. Therefore, A bar dot B bar becomes 0. In such a case, we say that the vector A bar is perpendicular to B bar, or A bar is orthogonal to B bar. In that case, dot product A bar dot B bar is 0. If I consider theta in between pi by 2 and pi, then this is the second quadrant, and in the second quadrant cos theta is negative. Therefore, positive into negative is negative. Therefore, the dot product A bar dot B bar is negative. So, dot product is positive, negative, or 0. It depends totally on whether theta is acute or theta is right angle or theta is what? Obtuse angle. Now, let us take a special case in this. Instead of choosing B bar, take some vector which is parallel to what? A bar, or the vector A bar itself. So, if I consider A bar dot A bar, then angle between A bar and A bar is how much? 0. So, I will define this as mod A bar into mod A bar into cos of what? 0. But cos 0 is known to be what? 1. So, this is mod A bar square So A bar dot A bar is mod A bar square. We may write A bar dot A bar as A bar square. So when I am squaring a vector, that means by notation I am taking the dot of the vector with itself. So A bar square means A bar dot A bar. B bar square means what? B bar dot B bar, etc. So A bar square is same as A bar dot A bar is same as mod A bar square is same as mod A bar is also written as A. So this is A square also. So if you square a vector, then whether you put a bar or not, it does not make any difference. So by notation, A bar square is same as A bar dot A bar is same as mod A bar square is same as A square. Moreover, if I consider the vector A bar as a unit vector, say A hat is a unit vector. So A hat dot A hat is simply what? 1. Likewise, we know that I, j, k are unit vectors. Hence, the dot of I with itself is what? 1. Similarly, I dot I 1, j dot j 1, k dot k 1. So dot product of unit vector with itself is always is equal to what? 1. So these are some special cases we have seen over here. Now, if I consider instead of A bar dot B bar, B bar dot A bar. So mod B bar into mod A bar into cosine of the angle between them. If you suppose think the rotation is this way, then still it is what? Cos of theta or cos of minus theta. So cos of minus theta is same as cos theta. So your final answer is same as this answer, because this is a number, this is a number, this is a number, and product of the numbers can be associated with each other. So B bar dot A bar is mod A bar into mod B bar into cos theta, which is same as A bar dot B bar. So one can say that A bar dot B bar is B bar dot A bar, means dot product is commutative, just like addition of the two vectors. A bar plus B bar is same as B bar plus A bar. So vector addition is commutative, just like that A bar dot B bar is equal to B bar dot A bar, means if you interchange the positions of the two vectors, dot product remains the same. So A bar dot B bar is equal to B bar dot A bar is called what? Commutative property. So dot product follows the commutative property. Now, let's see the geometrical meaning of this dot product of the two vectors. One more thing is to be noted over here. I, j, k are unit vectors which are mutually perpendicular to each other. Whenever two vectors are perpendicular to each other, their dot product is what? 0. So as I, j are orthogonal, means perpendicular, therefore I dot j is same as j dot k is same as k dot I is equal to what? 0. So because I and j are perpendicular to each other, their dot product is 0. Now we are going to see what is the geometrical meaning of A bar dot B bar, or what is the geometrical interpretation of A bar dot B bar. Now let us consider, suppose this is the vector A bar. So OA bar is A bar. Suppose this is the point B. Let me join from this, the origin, and suppose this is B bar. So OA bar is A bar, OB bar is B bar, and theta is suppose the angle between the two. Now what we do, we drop the perpendicular from the point B on this line OA at say M. So this is the vector A bar. Now observe that, suppose I had 2 points above the line, and if I drop the perpendiculars from both the lines, from both the points P and Q on this line L, at say M and N. Then M is called projection of P on the line L. N is called projection of Q on the line L. So whichever is the foot of the perpendicular of certain point on the line, that foot is called what? The projection of that above point on what? The line L. So if I join simply PQ, then this is nothing but what? The projection of this PQ on what? This line L. So by dropping the perpendicular on certain line, that distance between the two fit is nothing but what? The projection of segment on that line. So here OB, its projection is what here? OM. So OM is the projection of OB on the line OA. So I can say that OM is the projection of OB on OA. Rather, I may say OB bar is representing the vector what? B bar. So I may say this is what? The projection of the vector OB bar on OA bar. But OB bar is what? B bar. OA bar is what? A bar. So projection of B bar on A bar is nothing but what? OM. Now, this OM is the adjacent side in the right angle triangle OMB. So if I find cos theta from it, I get OM divided by what? OB. So I may write OM equal to what? OB cos theta. So projection of B bar on A bar is nothing but here what? OB cos theta. But distance OB is nothing but what? Small b. So it becomes what? B cos theta. So I may say projection of B bar on A bar is B cos theta. Now to convert this into what? The dot product. Because I may write this as AB cos theta. So I have B cos theta over here. So if I multiply simply by what? A, this product can be written as A bar dot B bar, means we can introduce in the projection the dot product. So let us multiply and divide by what? A. So AB cos theta is nothing but what? A bar dot B bar. Divided by A, I may write what? Mod A bar, because mod A bar is also written as what? Small a, or small a is what? Mod A bar. So projection of one vector B bar on another vector A bar is simply dot product of these two vectors divided by on what? Which vector is that? A bar. So we are dividing by magnitude of what? A bar. So projection of B bar on A bar means dot product of A bar and B bar, and on what? We divide by what? Its magnitude. Similarly, suppose we are finding the projection of AB bar on CD bar. So what we do? We take the dot product of these two, and the projection is on what? CD bar. So we divide by magnitude of the vector CD bar. So this is the formula to find what? Projection of one vector on what? The other. So geometrically, dot product means projection of one vector on what? The other. So this way we have seen all about what? The dot product of the two vectors and its property. We will see its application while solving the problems.